हेलो एवरीवन। इंट्रोडक्शन टू आईओ मॉडल्स हम पढ़ेंगे। तो आईओ मॉडल्स आर फंडामेंटल concepts in computer systems that describe how input and output operations are handled. This introduction will explore two key models: interrupt driven IO and concurrent IO. So interrupt driven IO. Interrupt driven IO is a method of managing input output operations in computer systems. It allows the CPU to efficiently handle multiple IO devices by responding to external events or interrupts rather than continuously polling the devices. How it works: detect event, interrupt, and process event. In an interrupt driven IO model, the operating system continuously monitors for IO events such as data being available for reading or space being available for writing. When the CPU then jumps to a special interrupt handler to process the event rather than constantly pulling the device. Advantages and disadvantages. Advantages are interrupt-driven IO allows for quick response time and efficient use of time system resources. Disadvantages: interrupt-driven IO can be complex to implement and debug, especially when dealing with multiple potentially conflicting interrupts. Trade-offs: the speed and responsiveness of interrupt-driven IO comes at the cost of increased complexity and potential for system instability. Concurrent I/O. Concurrent I/O is a model where multiple I/O operations can be performed simultaneously, allowing the system to be more responsive and efficient. This approach often utilizes asynchronous programming and techniques to manage multiple I/O tasks concurrently. How concurrent I/O works? Asynchronous request In concurrent I/O, multiple I/O requests can be issued without waiting for previous ones to complete. Event-driven architecture. Concurrent I/O is often implemented using an event-driven architecture. IO operations trigger events that are handled by a central event loop. Non-blocking IO. Concurrent IO uses non-blocking IO calls which return immediately without waiting for operation to complete. Advantages and disadvantages. Scalable performance, reduced latency, and efficient resource utilization. Concurrent IO allows for improved scalability as multiple IO operations can be executed simultaneously without blocking the main thread. By allowing IO operations to run concurrently, concurrent IO can be significantly reduce the overall latency experienced by users. Efficient resource utilization. Concurrent IO enables better utilization of system resources as CPU can be used for other tasks while IO operations are in progress. Comparing interrupt-driven IO and concurrent IO. Real-world examples of interrupt-driven IO: computer hardware, network interfaces, disk controllers, multimedia devices. Interrupt-driven I/O is commonly used in computer hardware such as keyboards and mic, where the device sends an interrupt signal to CPU when user input is detected. Then controller. Disk controller in computer and storage devices use interrupt to signal the completion of read or write operations. Multimedia devices such as sound cards to ensure that audio and video that is processed in real time without missing frames. Real-world examples of concurrent I/O: web servers, file servers, database engines, real-time application. Web server are concurrent I/O to handle multiple client requests simultaneously. Then database engine employ concurrent I/O to manage concurrent transactions and data integrity and high performance.